Good morning, everyone. I am Patricio La Rosa. I go by Pato, colloquially. I have been in Bayer working for almost 9 years, and it is really an honor for me to be able to speak about a journey that I joined in the middle. Technically, Bayer has been working on decision science, so analytics, since already more than a decade, transforming the internal processes, but also influencing our customer. This is so the first thing that we want to let you know is who we are, and Bayer is a life science company working on developing products to impact the nutrition, right, and also the food of our planet. They are pressing elements that motivate us to contribute with science, health for all, hunger for no one, which really speaks to the tracking or tackling two of the most important problems for a growing and aging population, which is nutrition and health. Bayer has 3 divisions: crop science, pharmaceuticals, and consumer health. Today I'm going to talk about our journey within the crop science division. We have the headquarters are in St. Louis and in Monheim. What do we do in the crop science division? What do we seek? We seek to impact agriculture, lead by innovation, right? Pioneer the sustainability efforts to ensure that as we are seeking to produce products that help drive agriculture in a better manner, but also being conscious of the use of natural resources. So sustainability is an important element in the practice of driving agriculture using digital technologies. Now, so therefore, we seek to deliver a world-class innovation and solutions for the farmers and also for our internal farmer. Something that maybe you haven't realized, that in order for us to sell you seeds, as we are going to speak, we also have to farm. So by default, given the landscape that we have, we can consider ourselves, or we would like to consider ourselves, as one of the largest farmers of the planet. Our operations are seated in multiple countries, more than 143, in multiple continents, and therefore we're required to understand the environments where we operate on. So there's a lot of need for science in order to work at the planetary level. Now, shaping agriculture, our mission, right? What we offer is seeds and traits, crop protection, and also digital farming. These 3 axes is what we're using today to impact the day-to-day farming operations for our commercial purposes, but also our internal operations, as I just mentioned to you, in the way on how we relate to our farmers in order to produce seeds. We also are understanding and learning those in order to drive agriculture for the whole world. We are looking to base ourselves on innovation. We have a very healthy investments in innovation, right? Pioneer the digital transformation, and today I'm going to talk about how we have been championing digital transformation for agriculture, specifically in our internal process. Time allowing me, I'm going to leave you with how we have been changing and transforming the supply chain of technically of our operation, where it shows the maturity that we have achieved after 10 years working on this. And finally, the sustainability part and component. What are we doing today to drive the capture of CO2, right? And also ensure that as we increase productivity and reduce our production variability to produce products, we are able to use less nutrients, water, and overall land in order to achieve the same thing. So produce more, consume less. How we transform. This talk is about a transformation journey. And I want to first summarize where we are today, and then I'm going to tell you the stages. Hopefully, if you are in a particular stage, it will help you guide, and it will serve as a roadmap for your own process of transformation in this space. Number 1 comment: digital transformation is not about IT transformation. It's actually about business transformation. Fundamentally, the reason for that is that technology changes too quickly. However, the business process changes according to the pace of the leadership. We can bring you all the maths, we can bring you all the stats, we can bring you Domino, we can bring you AWS, we can bring you Google. But if the leadership of the business doesn't change, nothing will take place. And I think many of you have come from experiences where the biggest frustration is what we call change of management, right? How do we influence the business to adopt the solutions so that we can really achieve what we call business transformation? Now, the important comment here is that at the center we have the digital and culture, and what we want to make sure is that as we are introducing new solutions, we don't want we as leaders to become the bottleneck of the digital transformation process. Therefore, you need to empower yourself by understanding what are the right products, what are the right operations that need to be automated or orchestrated, how are we training the people. I think here it's very important that our leadership, or we as leaders, are capable enough to define what is that digital target state that we want to pursue, so that then we can think of what are the right platforms, what are the right skills, right? If we understand, or we can envision that operations in the future, and we know how we want to technically operate, then we will be able to define what we need. Technically, we need to do somehow a moonwalking, right? We need to dance backward once we understand where is the end. So, digital transformation, right, as a whole, what does it mean for the farmer? A farmer today is taking 40+ decisions in order to produce a product. The farmer is thinking about my productivity, right? A farmer is talking about how do I control for pests, how do I control for weed, how do I ensure that there is the right nutrition to control the health, and also fertility. How do we technically take care of our soils? Now, on the other hand, Bayer technologies are looking to develop products and innovate in this space, providing crop protection, investing in plant biotechnology to be successful at controlling weed, right, ensuring plant health, and also identifying the right genetics to guarantee the yields that we want under a very changing environment. Finally, we also are providing solutions to technically drive the operations or provide recommendations, which is what we call digital advisors. The digital transformation process, from a business perspective, has impacted the whole cycle of our operation, all the way from product ideation, where should we invest, or what should be the right product for 20 years, to development, right? How do we technically create a pipeline of advancements so that we know how the products has to be technically, which are the best products for a particular environment? How do you manufacture those products? Think about this, that once you identify the right seed that you want, or the right hybrid seed for corn, for example, you need to be able to produce that. And for that, you need to engage in process of scalability. From a bunch of seed, you need to be able to get to 1 million seeds in order to be able to sell it. And then commercialization, right? Where do you position those products? How does your supply chain network, right, going across multiple continents, supports and becomes reliable and resilient to the changes that we have been facing? Think about what COVID has done to us, what climate how climate has impacted the operations in certain areas. Now, so transformation, the word transformation translates into IT capabilities. Right? In this case, we call them digital capability. And fundamentally in Bayer, we are supported on 3 fundamental elements. One is the platform, one is the data, and then one is the decision science. And I will talk about decision science today, and decision science is not a new term, it's not a hot word. Is different than analytics because it's the science of making decisions, invented in the 1960s, the first group of Houston University, which focused on how to transform processes by using data, analytics, mathematics, machine learning, and operational research. So decision science is a platform in itself for Bayer because it's rooted in understanding what are the business processes that we want to impact and how do we need to collaborate with our data colleagues and our platform colleagues in order to achieve a digital solution that goes along the digital transformation objectives. Our focus has been in areas such as precision agriculture. For some of you who might not be familiar with precision agriculture is, we're talking about 3 fundamental axes. How many seeds per acre do you need to plant? How much fertilization do you need to put in the environment? And how much water? 3 fundamental axes that goes along the way of sustainability. Now, the sophistication of a precision agriculture framework in the world is that you need to understand how to prescribe in different environments by soil, weather, right, and also according to the genetics that you have in hand. It requires scalability at most. Now, enhance customer value and technically customer experience. How do we know what our customer wants? And when it comes to the point where I don't have the right products for them, what are the most similar products that still could please that customer who have a different idea at the beginning of the season? Connected supply chain. How do I ensure that I take advantage, right, of the fact that the information content that has been created becomes available so that we can become resilient to changes or disruptions? Or that also that we can become more reliable. And reliability means the right amount of product, right, with the right quality, on time. Now, definitely the digital capabilities has helped us empower ourselves in the way of how we produce products. And fundamentally, we have developed digital capabilities that go across the whole enterprise, not just from the ideation perspective all the way to the commercialization. Now, from an evolution perspective, decision science maturity, right, is an evolution. We started all the way from descriptive analytics, so understanding what happened in the past, from our trial analysis. So did we do good? Is this the best champion? Using technically classical statistical analysis that has been driven from agriculture itself. Going to predicting what will happen. Which of the lines that I'm technically passing through my advancement pipeline will be successful? And can I actually guess that ahead of time? Prescriptive, how many seeds per acre should I be planting today so that I can actually control my production variability at the end? Or which field should I plant first so that I'm able to have enough capacity to process the material when harvest comes, right? Think about that when you're running operations in multiple continents and you're responsible for thousands of fields and you have facilities distributed, the optimization problem is huge. And timing is important in order to drive the operations. And then how do we develop better products? By understanding, right, how our decisions are connected, then the next thing that we're looking to pursue is to orchestrate. Think about that if I'm able to automate the different processes all the way from my pipeline, at the end of the day, I still need to have capabilities for conductor, the orchestra, right? It's not enough for every individual piece to do a beautiful song or play a beautiful song. If they're not properly orchestrated, the outcome will be awful. And so as you are maturing in the space of decision automation, you are moving towards decision orchestration. Now, three fundamental elements: platforms and best practices, right? Processes, alignment, and value measurement. Are you tracking what is the return of investment as you are maturing in this journey? And people, how are you training the people who need to engage with the technology, but how are you choosing the right talents to support your objectives? Where are you hiring? Are you developing pipelines in the universities to recruit the best talent? Are you partnering with augmented talent providers, right, that are there in the market offering services for us to accelerate our transformation? Do you have a career ladder to motivate and retain the personnel in place so that they know that their contributions will be meaningful and they will continue to grow along the journey? Right, these are questions that you have to ask yourself and therefore are key in order for us to move forward. And I will technically leave this slide with this one, best practices. This best practices speaks about our identity. Analytics teams working in these environments are actually manufacturing teams. Think about that. You are developing digital solutions to impact operations. You are technically, every single data scientist today is crafting a solution manually. Is deploying a platform for the sake of standardization. Nevertheless, the data scientists use mathematics and statistics and their own ideas in order to fulfill one particular objective, either predictive, prescriptive, cognitive, or descriptive. But how do you ensure that the quality of the work being manufactured by a data scientist is the same? How do you ensure that you reduce the intercepted variability so that the quality of the product being deployed in our operations is maintained? Those are questions that today we need to technically take care of in order to become a successful data science team. Now, as we move forward, we are grateful, and I would say grateful for the partnership with the business and also with the different platforms. And here in the audience, I have people from the data organization who has been technically partnering with us in order to impact the operations. 100+ business decisions across the enterprise resulting in more than 100 million return of investments as we have been impacting the operation. All the way with basic questions of which products do we need to develop? Or, for example, in the product supply space, how to technically route our track in order to reduce seed losses. I will tell you why does it matter. Because if you go too late to the field and your products get hit inside the track, the quality of that seed will reduce. So timing is at essence, right? Or the other way, what customers are likely to churn, right? Or what is the customer loyalty so that I can technically develop the right programs for engaging them and keep them in our portfolio, right? So these are examples. The important thing of that journey is that we put a stick on the ground saying that our objective is not fully to develop autonomous systems. Actually, at the end of the day, is to empower our people. Think about the word company. We are Bayer company. Therefore, the members of that company are companions of one journey. And as we are companions of one journey, our responsibility as decision scientists is to ensure that we can augment the intelligence of our personnel so that they can actually be successful at what they like to do, so that they do so the best. Now, this statement, don't take it like a cheesy statement. Oh, that's the cheesy statement of the talk. Actually, it's so important because when our company doesn't understand what is in there for you in digital transformation, what is in there for me, we start facing opposition because of, technically, job security. Oh, now here you come. You're going to develop a model which is going to automate the process. I don't have job anymore. And I will tell you that that component of the maturity of your journey is important to be addressed right at the beginning. We need to come across saying, what is in there for you, or what is in there for all of us as we are adopting the use of data, statistical analytics, and business processes under the umbrella of augmented intelligence. That's the umbrella that we like to technically pursue. Now, therefore, digital fluency. If you want your people to engage with new technologies and transform along the way, we need to seek to train them. Train the farmer, understand what are the user experiences that were going to be constructed so that they can engage and be the best at what they do or what they like to do. At the end of the day, decision science needs to be centered around a human who is taking decisions. In some cases, we might not want to do that because there are processes that could be technically or needs to be done in an automated manner, right? Specifically when a human personnel is at danger by being exposed to maybe an environmental hazard, right? But in other cases where accountability is important, meaning a person is responsible for granting the production of a particular growing season, or is technically responsible for ensuring, right, that a particular process is done accordingly to the law, then you're going to have a human involved in the process, right? So our autonomy is up to the law of each country, and autonomy is up to the ethics of the society that we're operating on. And I'm telling you that because we work in multiple countries, in multiple cultures, with multiple societal groups. Therefore, the use of augmented intelligence and automatization using analytics is heterogeneous. Now, our journey, and this is what we would like to show you. This is part answering and telling you the strategic stages that we went through after the fact, right? It would be funny to tell you, we thought about this and we will plan it actually accordingly. No, actually it's after the fact we're able to reflect on this. This is what happened to us. So aspirational, right? Curiosity, 2007. As you remember, some of you, back in 2002, neural network as a machine learning model perished. It was defeated by random forest. And for many years, right, artificial intelligence was then being ruled by different type of classification trees, and therefore everyone knows a random forest, and therefore it was being used quite often. It wasn't until later on in 2010, 2011 when it became alive again, right, under researchers in Canada and United States. So we went from an aspirational stage, understanding what is in there, to start testing and exploring few applications. Like, for example, understanding how can we impact breeding pipelines. What are the right crosses between a female and a male plant, specifically in corn, so that we could technically obtain, we could understand early on in the pipeline which will be the most successful genetic insertion. Think about that in order for us to deploy a product, it takes approximately 7 years to understand which will be the hybrid seed that I'm going to commercialize next. So when I'm producing and giving a seed into the hands of a farmer, you need to do moonwalking again and go 9 years backward. The 7 years of R&D and the 2 years of manufacturing. So it takes 9 years for us to put a new product in the hands of a farmer, right? And so we wanted to technically shorten that process and understand, can I actually, based on the performance and the data that I have, the environments that I'm growing, can I actually accelerate that and give us the ability to change our portfolio much faster according to the demand? Then we went opportunistic. We identify areas of investments. So we start talking about product supply. We start working more heavily in R&D, and you will see that some things were embedded and so on. It's strategic, right? Now say, wait a second. I'm not going for low-hanging fruits. I'm going to go for something really more pioneer. And I'm going to start asking myself best practices, how do I retain the personnel, how I develop the people, so that we can go into the integrated, and we can be talking about decision science integrated into the strategy of the company. And that's what I'm going to show you in an example here. So the experimental, right, for an applications, I think many of you at that time in agriculture, SAS was very popular. Statistical analysis, right? Descriptive analysis, trial analysis, and R, one of the most classical platform or open source platform for statisticians right at that time. So the first thing that took place, a team in IT was established, right? And then basic analytic capabilities with very low digitalization. Actually, no even question about which data should be automated so that the models could run faster. It was just understanding what to do. And then we went into opportunistic, right? So teams were inserted in business unit, actually connected to IT, but you see that the portfolio of tools increased. More personnel was brought into the organization, and we start now expanding into Jupyter, Hadoop. We were talking about scalability, right? Now we have more data to process. We want to process remote sensing images, soil data. So how do we do so? And so improving, right, embedding teams, technically developing ad hoc analytic capabilities. However, as you can imagine, Team 1 was using one set of tools, Team 2 a different set of tools, and you start understanding that as we were growing, hey, wait a minute, I didn't know that you were doing this. Oh, that's really cool. Multiple teams doing maybe the same solution. So the strategic one was say, you know what, hold on a second, let's create a community. And that's when the Center of Excellence was created from IT in order to coordinate, synchronize the different teams, and start talking about key capabilities like best practices, right? And also start talking about platform. How do we ensure that we have a team that is developing the platform so that we could all do model deployment in the same manner, that we could all scale the access to data through APIs, that we could technically start preventing data leakages. Maybe one team is accessing data that shouldn't be accessing, and then that is exposing our IP unnecessarily, or maybe involuntarily. And so that's when technically the organization start creating a proper platform concept in order for us to support the different groups that existed. So one of the key elements here, or the key creation, is science at scale, and we have in the audience the lead of science at scale with us, Pedro Veronazzi, right? And then start engaging with Domino. Now, also we start talking about learning programs, right? Data science learning program. How do we start training our personnel? And you may wonder, why do you need to train personnel? Can't you just hire them directly from the university? Well, it happens that we couldn't. And we couldn't, but we did have people that were interested in making a transition in their career. So here you have talented people with analytical skills, quantitative skills, but not necessarily data scientists per se, right? And so that's your trade-off. I go to the task force. I'm very ambitious. I want to keep driving the industry. I want to be number one. not second to anyone, but I need the people. So I need to train them. And then you will say, how do you train them? Well, we start establishing partnership and understanding the offers in the market, and even suggesting and modifying curriculums according to our needs. And we move on, then integrated, which is the era that I'm living now, and I'm happy to be a leader of this era, is basically being partners in the strategy design. And so from that perspective now, sitting at the leadership team, talking or being members of the extended leadership team as a data scientist, so to understand the business need, not of today, but of tomorrow. Influencing the business leaders in order to take the right decisions when it comes to transforming the business using data and analytics, right? Advising on what platform should be bought outside or what should be built inside in order so that we maintain our competitive advantage, right? Open data culture, right? And also, from a data science perspective, facilitate the democratization of exercising data science by technically having the right tools to deploy the models, minimize the bureaucracy, and so on. Now, so in order to make this journey effective, it's very important for us to have the key investments. Key investments in people, in processes, and technology, right? If you want to do this and you want it to do right, talk around, but make sure that technically you prioritize investments and understand how do you want to start this game or how do you want to accelerate this game. And these are the three axes that you need to keep in mind. In people, right, very key in order to retain personnel in a very hot environment. If we have multiple people wanting to do digitalization and transformation, now everyone is going to be seeking for resources, and those resources are limited. What are you doing today to ensure that those resources see in your organization a very attractive profile for technical growth, but also for business domain growth? The career ladder is key. We had this career ladder for long, and believe me, it was not activated. It wasn't until we activated that our personnel started liking it, what they were doing and what we were offering. So to give you an idea, from data scientist to senior data scientist to lead data scientist to principal and distinguished, you can technically create an expanded program where their responsibilities are increasing and their expectations as well in order to develop leaders of tomorrow. Now, I want to show you a very important topic, and here we have it. So, maturity. Once you start technically understanding what you need, and you feel that you're good in, let's say, automation, then you start actually asking yourself, well, my processes are a little bit more complex than that. So think about this. If I take a decision today on what to plant or how to plant, right? That's an agricultural decision. And what is the number of seeds per acre that I need to plant? And I have 4,000 fields. But I have few facilities to receive the material at the end of the season. I think it's easy to understand that you're going to have problems of capacity. If I have to manage multiple fields at a time and I don't control the timing, you're going to run short of people. So a decision at the beginning impacts the decision that you're going to take in the middle of the season or at the end of the season. So it's very easy to see that there are conditional statements embedded in your decision process. That led to a concept called decision orchestration, which is not the same as model orchestration. Decision orchestration is enabled through model orchestration, and I will show you a little bit what I mean by that. But it's important to understand that connected supply chain looks to technically unveil the data that flows and technically drive the decision-making process to achieve economy of a cost of goods and also efficiencies. So product supply, shaping agriculture together, we have to manufacture seeds, right? So we're a manufacturing team helping with the manufacturing process and the planning process of seed. So that's the beauty thing. So the complexity is represented here. We have chemistry, or what we call active ingredients, different type of seeds, right? Different countries that we operate, and multiple people that needs to be coordinated to produce seeds. So the challenges today, right, are several, right? From basically multiple conflicts or disruptions, different trends from weather environments, right? We also have energy issues, right? As well as technically changes in the profile or the footprint on how we are technically using the land today. Less land maybe to farm, more land for city. Right? And so the challenge here is we want to transform our traditional linear supply into what we call connected supply chain. So going from a linear interaction into a more technically proactive and connected interaction where the planning capabilities are much more connected to the manufacturing capabilities, which we call vertical orchestration, but it's also horizontal orchestration. So to give you an idea, what do you mean by that? Well, as we animate this, when we talk about supply chain, we have 3 supply chains in the company. One for the row crop seeds, one for vegetable, and one for chemistry. 3 different networks that are operating across continents. Some of them more regionally located, some others interconnected. And so from all the way going from the process, what we call raw material in crop protection all the way to the grower, or getting the seeds from the breeding foundations all the way to our commercial seed production and distribution. This is what we call the horizontal alignment. And vertical alignment is from a planning operation connecting to the execution. It's how do you produce the plan that you want to technically achieve in order to satisfy the demand. That's basically what we call vertical alignment. Alignment between planning and execution, where we're ensuring that along all the way of production, there is proper visibility. Now, that translates, the blue line translates what we call decisions. And decisions, you need to think about decisions as not of control, right? Think about that if I have a decision and technically I impact from a strategic perspective, now I'm impacting the flow of material along the way. So from a strategic perspective, decisions that impact the size of my network on how I'm producing, all the way to what am I doing on a day-to-day basis. That today is technically what we mean by decision orchestration, is connecting these decisions so that we can impact how the material flows according to our demand, but founded on what we call model orchestration, where you have platform for simulation, optimization, and coordination, building on machine learning models, but also on first principle. We can't forget the fact that it's not just black box modeling in the technical literature. We also have the ability to incorporate physics or biological laws in order to drive technically the decision-making process. So the model orchestration, the future of model orchestration is rooted on the integration of different type of models, right, that need to work. And simulation capabilities will allow us to understand if I do or if I take a decision here of one nature, what would be the impact in my ability to do an operation in a day-to-day basis? The only way for us to understand the impact of any intervention that you do in your process along the change of production is to technically virtually orchestrate decisions using simulation. So machine learning is one thing, but simulation capabilities will grant you this so desired holy grail technically orchestration in order for you to be successful. So what is required for this? We're building it. But what is required for this is to have proper strategic alignment, again, into product supply leadership, the digital leads that are responsible for digital information, the delivery teams, which is the IT folks, right? Data, product platform, and us, and technically full commitment and understanding of the value that this takes and how we drive that portfolio. So communication is super important. And I will tell you this, our way of transforming the processes of the company wouldn't be at the level of maturity that we have today if our leadership wouldn't have a change in the way on how they involve everyone in the process, sitting them at the same time on the table to have the right discussion. So organizational structures and commitment from leadership was key for us to be able to achieve this. So key to success, business engagement, right? Drive business transformation and therefore business value, right? Data decision and platforms, right, are going to support that digital strategy, focus on change of management in order to ensure that you realize the value, and don't forget that you need to nurture the skills and talents that you have acquired. With this, I finish the presentation. Questions? You can cut. Yes?
So I really like the center of excellence you talked about. in the training program, one of the things I've always struggled with is the concept of citizen data scientist, which is if we have the right tools, we can empower non-data scientists to deploy these very complex techniques and skills. And I always struggle with how you do that because data science is inherently complex. The techniques are difficult. And it's not just about if I give you an interface, you can suddenly run machine learning, you can run deep neural nets, and you can interpret it. So how have you, with the training program you've described, how have you brought data science in a way that is responsible and train up people to deliver the results you're looking for?
Very well. So governance and having what we call a data science life cycle. So the data science life cycle, I didn't put a slide on there, but what it does, it helps us to bring governance to the development of a product all the way from an ideation to a prototype, and then to a development, post-production, and maintenance. Every stage has a gatekeeper or a committee that will do the most important things. First of all, freedom to operate. You say, what do you mean by that? Well, if someone patented this, I can't work on it. Maybe I should seek for the license, right? So freedom to operate. Second, code reviews, right? That's technically what Pedro's group is technically driving for us. How do we ensure that we're coding things in the right manner? Science review. Are technically the laws that we're using in order to drive inference are correct? So you need to have a life cycle to help govern the evolution of a product and have the business also involved to understand whether the solutions are making sense. Thank you for the question.
Interesting journey, but since 2007 to 2019, you have evolved your tools and technologies that you are using. So whatever products or solutions you developed, they would also have to be transitioned and transformed into the new tools, and how all of those transitions was happening. Were those old systems not deployed, archived, like how that transition was happening, and how much work was spent in actually changing all of that code structure to fit the new standards and new technologies?
Thank you. So what he's asking is something that I suffer with, because it's a very important question. The technology, the change, okay, the rate of change of technology is much faster than what we can technically deploy. So you might be working for, let's say, we develop our own models too. So we don't just take models out of the shelf or from someone. We actually develop our own implementations, things like fast environmental classifications of billions of entities in an hour. So we have a theoretical team that does machine learning. So we finished that in, let's say, in a year and a half. And then when it was implemented, 6 months passed and the technology changed. What do? Do I keep investing and putting more money on it? That's the decision that I have to make. Or should I just leave it there, run maybe no at best, and then continue the journey? So the answer to that question on how to direct investments to technically revamp technology, right, versus invest on new things is according to the value that is provided. So this is very different when you are before development, when it's just a product that is being tested, versus when it's a product that is in production. For example, the cost of changing the technology or changing a product into new technology for something that is being used by so many people, the consequences are super huge. So maybe I should wait and then assess the technology, whether it is technically useful still, and maybe direct my attention to an area that it hasn't been developed. So it depends on the level of a stage and when that happens, but technically it's not an easy answer. It has to be weighed with respect to leadership of what are we going to do based on the maturity of the product that we have at hand and the scalability that we need to achieve. Yeah.
Got a question. It's a 3-part question, okay? You told me you want a tough question last night. So anyways, the first question is, I saw that you have about roughly, 450 models range in one of the slides. So assuming that's your total number of models you deploy, the first question is, when you deploy the models, do you have only one variation of that, or do you have the A/B testing of the backup models also available? So instead of 450 into 3 or into 4, so you have about 2,000 models that you do A/B testing, and based on which model skews more, validity is more, you switch out the models. That's question one. Question two, do you do regional adjustment to your models? Because if you have 450 and each model will not perform same in each region, so do you have variations? So apart from the backup model for the skew and validity, the regional variation, how many variations do you have? And the second question. The third question, how many of a business input goes into that in the model skew validation, switching and A/B testing versus technical decision? In other words, does technology decision makers make the decision, or your business decision makers saying that, this model sucks, I want it changed? What kind of input you get from business?
Oh, great. Okay, so question number one. Model factory, right? Do we have, 450 models deployed, but it's not that we just develop 450 models. We have a battalion of models, and we make them compete. Actually, we don't make them compete just virtually. We also make them compete experimentally on the field. So something that differentiates us from many other companies is that we are willing to technically test in our production environment, true production environment with growers. We are able to dedicate part of our fields to test a particular agronomical recommendation. And you say, well, isn't it enough a cross-validation scenario for you to be confident that you did the right thing, right? Well, yes. However, the full involvement of the grower goes through their ability to understand what is exactly that we are asking them to do. And showing them, okay, we told you that technically this is going to increase yield, right? Well, am I seeing it in the field? Right? And that's because we have a relationship, right? We are respecting the growers is providing or working with us, but ultimately he's a farmer. And so experimentation in the field is key for us to compete. And that's where we put super mini models to compete with one another in multiple countries.
How many such models would you have at the same time?
So technically it depends on the level of investment. The recommended number is no more than 4 because of the time that it will take to develop. That means that you will have 4 parallel instances for model development.
All the 4 will be deployed at the same time?
At the same time and tested in the field before we say we're going to deploy it everywhere. So to the second question, heterogeneity, so standardization versus harmonization. People like to have one solution driving across the whole world, different regions. Why? Because we want to have less products to maintain, right? It's a maintenance issue. So if you have multiple solutions running, one in LATAM, one in, let's say, North America, right? And the processes are driven in a different manner, think about what will that imply to your IT infrastructure. You will have to have a lot of resources for support and knowledge transfer. If this model works this way, but this one works differently, right? So maybe I have 1 or 2 or 3 people just to maintain this bunch of models. So people think standardization, but think about that agriculture is heterogeneous. Our environments, or growing environments in the United States are not the same in South India. I mean, right? They're not the same. We could find similarities. So the message is seek standardization when it's technically biological justifiable or technological justifiable. And create technically a alignment or business alignment in processes, which we call harmonization. So standardize when it makes sense, right? So that's how it goes. So therefore, yes, we do have models that are different in particular regions, justified under the assumption that the agronomics behind are different. It's the same structure, it's just that the parameters are different. And the third one was, if you remind me?
Business. How much business?
Yes, so in the life cycle, as I was answering, how do we drive the progression of these models through the cycle? The business is a member of it. And the reason is that in some cases, you're going to be surprised, but you don't have ground truth. Technically, in the absence of ground truth, you want to have a simulation to understand that the model is better, right? But in some cases, you don't have ground truth. So how do you drive with the business cases where their expert agronomist is telling you it didn't work, but it didn't work because of the model, or it didn't work because sabotage, or it didn't work because technically we didn't collect the right data. And so the business has to be involved in actually processes that are so complex like this.